Previously, we talked about the graduate attributes. There are 11 graduate attributes as defined by IEA. This graduate attribute shall become the program outcome of the engineering program. The graduate attributes specifically outline the characteristics and attributes as required from engineer graduates to be able to function as an engineer in the competitive global markets. We will need to look into the statement, every single one of them. Make sure all the elements and standards as specified in the graduate attributes are being incorporated in the program. Now, if you look at the statements of the graduate attributes, there are a series of WK. These WKs are the knowledge and attitude profile as given in the slides here and also here. There are a total of 9 WKs. This will define the knowledge and attitudes to be incorporated within the program. There are various types of knowledge: natural science, mathematics, engineering fundamentals, specialist knowledge, engineering design and operations, engineering practice, roles of engineering in the society, knowledge in the research literature, as well as ethics, including the behavior and conducts. Among these knowledge and attitude profiles, there should be components of sustainable development. This will have to be in line with the 17 United Nations Sustainable Development Goals. If you put all the knowledge and attitude profiles together, you will see that they are complementing each other's. We can do some simple classifications of these knowledge profiles. There are knowledge-based, application-based, and also searching for the knowledge. Now, WK1, 2, 3, and 4 are categorized under the knowledge base. The most fundamental, it will be the natural science plus the social science. That will be under WK1. Next, it will be the engineering fundamentals. The scope becomes narrower, skewing more towards the engineering. Now, these engineering fundamentals are mainly relying on the natural science plus social science. This will be the WK3. Higher up, it will be the specialist knowledge. That will be a more advanced version of the engineering knowledge in the forefront of engineering field. Therefore, you will see WK4 is actually building on WK3. Now, all these WK1, 3, and 4 involve mathematics. There are a lot of calculations specifically used in terms of analyzing the problem and designing for the solutions. With that, all this shall be based on the WK2 mathematics. Knowing their relationships, we know that when we need to design a program, most likely the courses classified under WK2 and WK1 shall be introduced first. Normally, you will see this in the first year of the engineering program. Once you have all the basics established, then engineering fundamentals courses shall be introduced. The examples of engineering fundamentals include the mechanics, engineering static, engineering dynamic, fluid mechanics, soil mechanics, theory of structures, strength of material, and so on and so forth. Next level, it will be specialist knowledge. And these are the courses that are being introduced in the third year and the final year of the engineering program. When we talk about the knowledge, it is about the conceptual part of the knowledge, mostly due to what or why. Understanding situations, knowing the rules and principles, know the relevant laws, and etc. Next stage, it will be the applications of the knowledge. This is more towards the contextual and the technical know-how. You will need to first establish the knowledge, and then within the knowledge that you have established, it should be introduced progressively. Now, having those knowledge, we are only just halfway through. We will need to be able to apply those knowledge. This leads to us WK5, 6, 7, and 9. WK5 is about engineering design and operations. And when it comes to the design and operations, you will need to make sure there are considerations and incorporations of the Sustainable Development Goals. There are also engineering practices, as well as the role of engineering. Now, when it comes to the role of engineering, you know that you are servicing the society. You are also at the forefront of the development of the country, and you should always put the Sustainable Development Goal as a part of this WK7. Now, WK5, 6, and 7, they are interrelated. When it comes to the engineering design and operations, it is closely related to engineering practice. You have to consider the engineering practice in order for you to custom-make the design and operations meeting the situations. Not only that, the WK5 is also governed by the latest development of the technology. And then the engineering practice shall be based on the roles of engineering. And all this, the design, the engineering practice, and the roles of engineering will be governed by the ethics. Now the whole thing has to come together. Having the knowledge and having the ability to apply the knowledge. You will need strong fundamentals in terms of the mathematics as well as the natural science. You will need to be very well versed with the knowledge, and you should have the ability to apply those knowledge. While applying those knowledge, it will have to be governed by the ethics and also considerations of Sustainable Development Goals. Having these two items here is not sufficient, as you are looking into the continuous growth of the engineering field. There are rapid development in terms of the technology and the latest practices. Therefore, you will need to have the ability to sourcing for knowledge. This leads to WK8 in terms of the research literature. Now, knowing the relationship between the knowledge and attitude profiles, knowing that the whole things here need to come in one piece, you cannot miss any item here, otherwise the whole thing will be incomplete. Therefore, there is a need for you to check the engineering program that you have designed constitutes all the knowledge profile. Nevertheless, IEA did not make specific the weightage and the ratios in terms of all these WKs. The flexibility is given to you, which you can design the weightage as appropriate. If your goal and strategy is more towards the applications, you can skew your curriculum, paying more emphasis on these areas. Of course, this is provided that the students enroll to engineering program, they possess strong fundamentals in the first place. Now let's say your program will need to be competing among the academic institutions that you may have difficulties in guaranteeing the qualities of the students' intakes. You might need to pay some emphasis in terms of the fundamentals in order to build up the competency of the students. As without good fundamentals, the applications shall be an issue. This is very much dependent on the conditions of your programs as well as the markets that you are targeting. The bottom line here, it will be you will need to make sure all the knowledge and attitude profile has been covered within the program. Not only making sure they constitute all the knowledge and attitude profile, you will need to observe the interrelationship between those knowledge and attitude profiles in order to ensure the integrity of the design of your curriculum. Now coming back to graduate attributes, they have linked the graduate attributes to the knowledge profiles, and you will see different graduate attributes referring to different knowledge profiles. To make it simple, let us look at the mapping here. We have 11 graduate attributes. These 11 graduate attributes shall ultimately become the 11 program outcome. When it comes to the design of the program, you will need to make sure your program outcome will be at least equivalent to the graduate attributes. The simplest ways to do this is that you have the program outcome to be totally identical to the graduate attributes. You may also follow the proper sequence of those attributes that give you PO1 to PO11. Looking at the designated knowledge and attitude profiles, this will be the mappings. PO1 and PO2 will cover knowledge profile 1 to knowledge profile 4. This is about engineering knowledge and problem analysis. PO3 is about design or development of the solutions. That will be knowledge profile 5, which is about the engineering design and operations. PO4, it will be investigation. That will be WK8, which is related to research literature. Next, it will be the tool usage. This is referring to WK2 and WK6, as it involves the technologies, technique, resources, and various IT tools, and you're going to use them for numerical analysis, data analysis, statistics, information science, and etc. All these are interrelated. Now, PO1 to PO5 or WA1 to WA5 is about analysis of problems, synthesis of knowledge, and development of the solutions. PO6 and PO7 is related to the responsibility of engineers. It is about the engineers and the work and the ethics. The relevant knowledge profile shall include WK1, 5, and 7 for PO6 and WK9 for PO7. WK9 is related to the ethics. Next, PO8 to PO11 are the attributes required in the workplace. These include the individual and collaborative teamwork, communications, project management and finance, and lifelong learning. For PO9 and PO10, it is not designated to any of the knowledge and attitude profiles, as these are generics As for PO8 related to the teamwork, WK9, which is the ethics, shall be relevant. As for lifelong learning, WK8, which is the research literature, shall be relevant. What you see here, if you design your program meeting the program outcome properly, theoretically, the graduate produced by your program will have all the graduate attributes as required by IEA. At the same time, you should have all the knowledge and attitude profiles in place. And therefore, you will expect the graduate should be able to perform well and stay competitive in the global market. Of course, this is provided that you design your program properly, having really strong correlationship between the POs and the knowledge profile, and between the POs and the graduate attributes. And also you will have to make sure there are integrity and interrelationship between those knowledge profiles.